a vulnerability appears in a system no one wants to touch. Not because it is unimportant, because it is too important. At an insurer, it might be the claims intake service. The older system that receives a claim sends it into review, triggers fraud checks, routes it to the payment rules, and feeds member communications. In a bank, it might be payments. In manufacturing, scheduling. In logistics, dispatch. Or in a digital business, customer identity. It is not the glossy front end. It is the older layer beneath the work. The service, dependency, integration, configuration, or access path that survived 3 modernization programs because the business still runs through it. Then, Mythos finds something. An aging library, a brittle configuration, a permission path that reaches too far, or a component that should have been patched months ago. At first, this looks like a technical finding. Then, it becomes an enterprise problem. Who owns the service? Who can patch it? What breaks if the fix goes wrong? Does regulated data pass through it? Who approves the change? And what evidence proves the risk actually went down? That is the real Mythos problem. Not that AI can find weakness. That's important, but discovery is only the first move. The deeper issue is that many enterprises are becoming easier to read than they are to govern. Mythos did not create the crisis. It exposed the ungoverned enterprise. My name is Vlad Stoyanovsky. And this is the Sovereign AI Enterprise. I look at how AI, agents, governance, infrastructure, and geopolitics are changing the way institutions operate. And in this video, I want to focus on one specific shift. What happens when AI makes enterprise weakness easier to find than it is to govern? The shift is simple. Before, discovery moved closer to human speed. Periodic scans, manual reviews, specialist analysis, backlog-based prioritization. Now, frontier cyber models can compress that timeline. They can help connect code, dependencies, configurations, access patterns, exploit write-ups, logs, tickets, and architecture notes. That does not mean the model is always right. It does not mean expertise disappears. And it does not mean context no longer matters. But it does mean the cost of seeing certain kinds of weakness is falling. And once discovery gets cheaper, visibility is no longer enough. Seeing the crack is not the same as knowing who owns it, whether it matters, what response is required, or how to prove the risk changed. The vulnerable service was never truly invisible. Pieces of the truth already existed across the enterprise. Repositories, dependency files, configuration histories, architecture diagrams, change tickets, monitoring logs, security scans, access policies, and old incident notes. The problem is that those pieces were scattered across too many systems and too many teams for any one person to read quickly. That is what frontier AI changes. Generative AI works well when there is a lot to read and a lot of repeated structure to compare. Text fit that pattern. Code fit that pattern. But cyber fits it too. Vulnerabilities leave evidence. Code, CVEs, exploit write-ups, patch note, dependency files, configurations, access policies, tickets, infrastructure as code. And the frontier model can read it at scale. But the model cannot replace validation. In the claims example, it may identify a vulnerable component while missing the batch processing window, overstating exploitability, or overlooking a compensating control already in place. But the finding still has to be tested against operational reality. And operational reality is where the problem gets harder. The ungoverned enterprise is not an enterprise without governance. In fact, large organizations have governance everywhere. Security policies, architecture standards, CMDBs, vulnerability scanners, ticket queues, risk committees, change boards, identity controls, compliance programs, incident processes, audit trails, executive dashboards. The problem is not absence of governance. It is fragmentation. Let's return to the insurer's claim intake service. The security team sees the vulnerable library and opens a high priority ticket. The asset inventory shows the service exists, but the listed owner moved to another role 18 months ago. The application team knows the claims intake codebase, but not the infrastructure image it runs on. The infrastructure team can patch the runtime, but not the vulnerable component bundled into the application. Identity can see the service accounts connected to the workflow, but not which ones are still required for claims routing. Compliance knows regulated health data passes through the workflow, but that context is not visible in the vulnerability queue. Operations knows the service cannot be taken down during nightly claims batch processing, but that constraint is not reflected in the risk score. And the business owner understands the risk of breaking claims payments, but not the cyber risk of leaving the vulnerability open. Each team may be doing its job, but the enterprise still cannot move as one system. And that is the governing problem Mythos exposes. The finding is not just a vulnerable library. It is a claims continuity issue, a regulated data issue, an identity issue, an application remediation issue, an infrastructure issue, a vendor support issue, and an evidence issue. The risk does not respect the org chart, but the response usually has to. And that is the difference between having controls and having control. The ungoverned enterprise is not missing policies, tools, or approvals. It is missing the connective tissue that lets them move together when risk appears. Now, add Mythos to that environment. IBM Consulting has said the time to exploit published vulnerabilities has fallen from an average of 23 days to as little as 9 hours using some frontier models. The exact number matters less than the direction. The window is compressing. And when the window compresses, the operating model gets tested. Faster discovery does not fix the claim service. It creates a decision point. Is the vulnerable component actually exposed to anything that could use it, or is it isolated in a way that limits the risk? Does it touch regulated data? Is it active in the claims workflow? Is there evidence of attempted exploitation? And is this urgent risk or a latent risk that still needs to be reduced? Then the insurer has to understand the business consequence of each possible response. A rushed code change could break claims routing. A runtime patch could affect other services on the same image. A tighter access policy could block a legitimate service account. Isolation could disrupt fraud checks or payment rules. Waiting for the vendor-supported upgrade could leave exposure open longer than security is comfortable accepting. But taking the service down during batch processing could delay payments and create provider complaints. This is why more visibility does not automatically mean more control. Because the bottleneck is not only technical, it is operational. And the exposed weakness rarely lives in one place. Reducing the risk may require a code fix, a runtime patch plan, an access review, a batch window constraint, extra monitoring, a vendor escalation, a compensating control, and proof that the exposure actually changed. That doesn't mean these actions should be automated, because automation can create its own incident. A model-generated fix that breaks claims intake is not resilience. A patch that removes one exposure but delays payments has moved the risk from cybersecurity to operations. And the permission change that blocks the wrong account may reduce access risk while creating a service outage. The answer is not faster motion, it is governed speed. Some actions should be automated or pre-approved because they are low risk and high value. Enrich the ticket. Check reachability. Identify active service accounts. Correlate the vulnerability to known exploit patterns, or generate a proposed fix. But other actions should require explicit approval because they change production behavior, modifying application code, patching a shared runtime, revoking access, isolating the service, applying a compensating control, or accepting residual risk until the vendor upgrade is available. That is the distinction Mythos forces into the open. Finding weakness is getting cheaper. Acting safely is becoming the bottleneck. So how should enterprise AI leaders think about this? A governed enterprise is not measured by how many vulnerabilities it can find. In the Mythos era, discovery will keep getting cheaper. The harder test is whether the organization can turn a finding into a controlled, verified, evidence-backed response without reconstructing the truth by hand. That test comes down to 5 questions. First, what is exposed? For the insurer, answers cannot stop at claims intake service. It also needs to answer questions like, where does it run? What connects to it? Which identities can reach it? What data moves through it? Which workflows depend on it? Second, what matters? Technical severity is a signal. It is not a decision. The same vulnerability means something different in an isolated test environment than it does inside a claims workflow that touches regulated data, supports provider payments, and triggers member communications. The enterprise should rank findings by business consequence, not technical score alone. Third, who can act? A model can recommend. A scanner can flag. And a ticket can route. But who can act? If authority is unclear, the enterprise loses time exactly where Mythos has made time more expensive. So, define action rights before urgency arrives. What can be automated? What can be pre-approved? And what requires named authority? The enterprise should not be deciding who has authority in the middle of the incident. Fourth, what response is required? Not every vulnerability is a patching problem. Sometimes the response is a code fix. Sometimes it is a runtime patch, configuration change, access review, network isolation, vendor escalation, monitoring rule, rollback plan, temporary compensating control, or business decision to accept residual risk until a safer fix is available. And sometimes the response is not exotic. Apply the available fix. Move off a down-level version. Use a supported configuration. Or remove a dependency that should no longer be there. AI may accelerate discovery, but many first-order defenses are still basic operating discipline. Fifth, what proves the risk was reduced? A closed ticket only proves that a workflow ended. It does not prove risk went down. For the insurer, proof means showing that the exposure changed. If the response was a patch, prove the vulnerable version is no longer running in production. If the response was an access change, prove the risky service account can no longer reach the claims intake workflow. If the response was isolation, prove the vulnerable component is no longer reachable from the relevant network path. And if the response was a compensating control, prove that the control is active, monitored, and mapped to the risk it is supposed to reduce. The fix is not complete when someone changes something. It is complete when the organization can show that the risk was reduced, transferred, contained, or formally accepted. That is the governability test. What is exposed? What matters? Who can act? What response is required? And what proves the risk was reduced? The governed enterprise is the one that can answer those questions before the vulnerability becomes a meeting, a scramble, an exception, or an outage. And this is where the Mythos story becomes an enterprise AI story, because the same pattern will show up wherever AI compresses time. In software delivery, agentic workflows, data movement, infrastructure change, cyber response, and the operating decisions that connect them. That is why the project Glasswing Muse matters. IBM joining Anthropic's initiative is not just another cyber announcement. It is a signal that AI-era defense is moving from isolated detection toward coordinated response. Code, infrastructure, identity, operations, open source, evidence, and business context moving together. The specific product and vendor names matter less than the pattern. The market is recognizing that faster discovery only helps if the enterprise can govern what happens next. So the point is not dependence on a single model, vendor, or initiative. The point is the operating posture, a system that can absorb faster discovery from any source and still respond through governed, repeatable paths. That is what move faster without increasing risk really requires. Not just faster tools, faster governed decisions. A sovereign enterprise cannot rely on obscurity, delay, or institutional memory to survive the next finding. It needs to know what it runs, what those systems depend on, who has authority to act, what cannot break, how the response will be verified, and what evidence proves the risk actually changed. That is what Mythos exposed. Not a new crisis, an old one made visible at higher speed. Because for a long time, complexity bought time. Now, frontier models reduce that time. In closing, a sovereign enterprise does not begin with independence. It begins with self-knowledge. So when the next vulnerability appears in a system no one wants to touch, the question is not whether the enterprise can find it. The question is whether the enterprise already knows what to do with it. If the answer has to be reconstructed after the clock starts, Mythos has exposed more than a vulnerability. It has exposed the operating model. I wrote the full version of this argument on Substack, including the deeper enterprise example and 5-question governability test. The link is in the description. And if you're leading AI, security, architecture, or enterprise transformation right now, this is the question I would leave you with. As AI makes your enterprise easier to read, are you making it easier to govern?
The data flows, a constant stream, shaping futures, chasing every dream. Complex patterns and sights unseen, a new era, sharp and keen. The world is changing, can you feel the pulse? A deeper vision beyond every impulse. Enterprise, geopolitics, AI.